Okay, so I guess my screen is sharing over here. So my today's topic is Flutter and Web3. We will be creating DApps example like applications which are decentralized applications. Okay. So before going on to the topic, we should know who is presenting you. So my name is Shrihriday Bhagwat, and Vijay has given a very nice introduction about me. I don't think anyone can surpass that intro. But here are some of my socials that you can see. You can follow me on Twitter, on Medium, and on CodeAmy on YouTube channel, where you can read my articles and watch my videos. And I just love to share about my knowledge that I've gained from this community. So let's begin ahead without taking much time. So what we will be learning, or what I will be talking about, a short introduction to Web 1 and Web 2 before jumping to Web 3, then an introduction to Web 3 and why we need Web 3, what are the apps, what will we be building, setting up the environment and introduction to the environment, smart contracts and Solidity, linking smart contracts with Flutter, and creating kick-ass Flutter apps. And going with the flow, how to be on Shark Tank to get funds for our project, because that is very much important currently with the trend going on. So let's get started. Now, what is Web 1? Web 1 meant a simple website when it was created long time ago, not much design, only text, one-sided communication where the users used to surf on Web 1 were only able to receive the information. They were not able to send information or transfer the information. So it was just a one-way communication from internet to our computers or mobile phones or wherever we were using our web. As time went, the Web 1 evolved into Web 2, and it was a new, what we say, a new wormhole into the web area. So the Web 2 increased the functionality. Internet users could now post images and videos on the internet. Social media and e-commerce bloomed. Okay, there was new way of interacting with web. Now we see Facebook, Instagram, Twitter, even this online conference that we are having right now. I'm posting my screen and my live video from here, and you guys are able to watch it. So this was all possible because of Web 2, and Web 2 was a huge leap from Web 1 to Web 2. Now, if Web 2 is so good and so nice and everything is happening so globally nicely, then why do we need Web 3, right? So there were some problems with Web 2. The data gets stored in company owned servers. For example, there is a server which hosts all the data. So whenever we see that data has to be stored somewhere. So these companies could use that data which was stored in their server, which we host or which we post. For example, when you're posting images on Facebook, that image or that video is stored somewhere. Now, no matter how much they say it's encrypted, we as developers, we know how the backend works. And if someone wants to, they can actually deep dive into the backend and they can retrieve the information. For example, the moment when we share something on Amazon, you see that ads everywhere on Google. So you can see a small clip on the right, wherever I go, I see his face. Yeah, that is true. That was happening in Web 2. And the companies, they were putting all dominance over other companies. But that was a small part. The major drawback was this company, they understood that they can alter our situation, they can alter our mindset, and they can provoke people. So that was the thing that happened before, and that's why Mark Zuckerberg was called in by lawyers and the syndicate team. That was some of the problems with Web 2. And this is where Web 3 comes to our rescue. So Web 3 is decentralized, meaning there is no central system, okay, or there is no one system which will control the entire internet. It is powered by blockchain, hence a dominance over internet. Everyone is free over there. Difficult to track user activities and internet footprints. Like we all know, the bloom of Bitcoin exposed how blockchain work, and people were exposed to the working of blockchain, and they were intrigued by blockchain, which was that it doesn't leave any footprints, and we could just go on, and the reverse tracking is very difficult. So we use this blockchain, which is very hard, and impossible to change the record. So once the record is done, it stays over there. Okay. So if you want some links, we will provide in the description. Also at the end of topic, I will give you some links which you can refer to about blockchain. Now, what are DApps? DApp is an acronym of decentralized application and not dope apps. To be honest, when I read DApps at the start, I was like, someone just came up with dope app kind of term, but my mistake. So just want to clear that it is not dope app, but DApps, meant to run on decentralized computing system like blockchain. It was first introduced by Ethereum blockchain, which is built using smart contracts. So what we will do is we will create some smart contracts that we will track and monitor our account. Okay. So what we will be building? We will be building a to-do app. We will be using Solidity to write smart contracts and Flutter Web3 Dart package. Then we will be using Truffle for developing smart contracts locally. The Gnash is a nice library toolkit that provides a local environment of blockchain, Ethereum blockchain, and again Flutter to build the front end, because Flutter is cool and Web3 is cool. So we are integrating Web3 and Flutter together. So we will just fast track the application. There are some things that we will be needing. First of all, we will be needing Truffle to be installed globally. So just a single command npm install globally Truffle. So npm install -g Flutter will install Flutter globally. Okay. So after this, what we're going to do is, let me just start with my code over here. So I'll just minimize this over here, and okay, just let me minimize this also, taking this screen from here. I think it is visible and the font is also visible. Yes. So this is the project which we are creating right now. Okay. And in this project, it is a starter project, and I will give you the link of this project. And it is a basic to-do application. So it will have two screens. One is home screen that will, just let me make it full. Yes, over here. Yes. One is home screen, in which we will see all the to-do items that we are going to add in this. Second screen will be a add to-do screen, where we will be adding the tasks, or let's say our reminders, or whatever you want. And this over here is what is the most important folder. So now you won't be having this contract folder if you will download my starter project. So we are going to open the terminal, and over here we will run, or first we will navigate to our contracts folder like this, and we will just create or initialize Truffle inside it. So the command is Truffle init, and once we init the Truffle, it will create, okay, it will create these folders inside. So for starters, I'm going to hit a n over here, but you can just create yes and create all those folders. Okay, so I have created this. So we have this contracts folder over here, and inside contract folders we have extra folders. So let me get you through this extra folders over here. So this contract folder contains all the smart contracts. So there is migration SOL, or SOL means Solidity, which is present. The to-do contract is not present, that we will be creating. Then we have this migration, which deals with all the migration scripts that Truffle handles and communicates with Gnash. Then we also have a Truffle over here. We also have a Truffle config.js. It is a Truffle configuration file over here. Okay, so now we have done this. So we have to create a to-do contract.sol. .sol means Solidity over here, and this is our smart contract that we will be used to communicate with our blockchain. So you can just copy this, and actually it is present in the starter pack. Okay, it is present in the starter pack, and this is the license that we need, and we are importing the Solidity version from 0.4.22 to 0.9.0, in between this. and we have created a contract here, and I've named it as to-dos contract. Okay, because we are going to create a to-do app. Now we are first going to create a value which will hold all the count of the to-dos that we have. So if you have one or two or three, whatever to-dos we have, we are going to hold the count over here. Okay, and then we are going to create a struct. So I don't think that I have to explain you what a struct is, but it is kind of a data structure which holds the data in what kind of data that we need. So we are going to create a struct of to-dos, and it will take an uint. So uint is kind of undefined integer. Okay, so it is not defined, so it has a bit size of 256, and we are going to store our id over here. Then we also need a string value which will be a to-do title, because we need a title for our to-do list. Then we need a string about the category. So will it be a fun game activity, or will it be a school activity, office activity, etc. Okay, we also need a timestamp, because when the activity was created, it was created in the afternoon, evening, and what is the due date. So depending on that, we will need the timestamp of the activity. So next, we are going to map all these to-dos into a public to-do account. Okay, so we are mapping it over here, and below this, we are going to have created a constructor. Okay, it is a public constructor which is setting the to-do count to 0, and we have created some event. Now this event are public, what we say, this event are fully customizable. You can create an extra event, but taking some of the common events in the mind, I've created this. First is to do added. When our to do in the event list will be added, okay, it takes the id. Then is to do deleted, when we want to delete a to do that we have added into the list. And the third event, which we're not going to use but I've actually created, is to do edited. For example, you have created a to do item in the list and you want to edit it, maybe it's spelling, or you want to change it, or you want to add something, then you can edit it over here. Below is a function. Okay, so now these are the functions, and this just takes a to do count function, and we just add all the data of the items over here. For example, the count, the title, the category, the timestamp, etc. Okay, and coming down, so this count means the id. Okay, we are sending this id over here like this. Okay, and we are going to emit the to do added. Now what emit does in Solidity, kind of emit is kind of a return function, like we usually return in Dart, right? So this emit will return this function, and with this return we can communicate with our blockchain server. Okay, and over here we are increasing the increment value of to do count. So this is our add to do function. Okay, then this function is the delete function, where emit to do delete id, we are just deleting it from here. Then we have the edit function over here, which will edit the to do that we have added. Okay, an it takes a UNI to 256 ID. It takes a string memory to do title. Now there is this new keyword memory, which I will explain further when we go into the next screen of our application. Okay, so this is done over here. I hope you are clear with these topics over here. We have done. Now what we have to do is you have to compile this smart contract. Okay, without compiling, we cannot work this contract. So to compile, what we have to do, we are going to come to terminal, and into our contracts folder, we are going to just write a command called as truffle compile. Okay, over here. And let's see, it works properly. Yes, see, now there is no error over here. We got compiled successfully using this commit. This is the latest Solidity that we have used. Okay, and when we run the following command, truffle compile, a new folder over here was created in contract. You can see build contract, and there is migration.js, which is a JS folder over here, and there is to do contracts.json folder. Sorry, JS folder over here. Okay, JSON folder. So these folders, they have the data and the properties that we are going to need and we will be using. For example, inputs, to do edited event. Okay, and we can explore them a bit, but it will be time consuming. So right now you can just remember that they are just JSON values or just a project samples that we need. Okay, this is very important, the API that we are going to use it in further. Okay, so I'm going to close this over here. Now what we have to do is, now we have to create a migration directory over here which is already present, and in this migration directory you can see you will be having one initial migration. Now what is this migration? Like, we have created contracts over here, right? But we have to migrate those contacts from our local server over here to our Gnash server which we will be using. Okay, so we will have to migrate them. So how we'll migrate them is, first we'll have to create a to do contract migration over here. So I've written it, so I will just uncomment this. It is normal JS file, const to do contracts artifacts require to do's contract. Now this should match over here. If it doesn't match, then it would create a problem. Okay, so this should be type sensitive. So we are okay here. So we have created this module over here which we are going to export, and we are going to deploy our to-dos contract. Okay, so let's get with that. So before before we export them, we have to open Ganache. Okay, so this is Ganache. You can download them and you can start it, and you will be seeing that we have the balance of ETH. We have 100 balance over here, and this is a server on which the Ganache is running. This is the network ID. Okay, so if our Ganache is running very nicely, then we can minimize and come back to our we have to come back to our terminal, and over here we will migrate. So the command is simple, truffle migrate. Okay, and this will help in creating the migration that we're going to need. So you can see there was no error over here. Both the migration took place, initial migration and to do migration. Okay, both the migration took place. And now getting back to our Ganache over here, you can see first it was 100, but now it is 98. So we have used some of the ETH balance that we require. Okay, why? When we migrated. Okay, when we migrated our contracts. So minimizing this over here, we have migrated it. Now let us come back to our contacts.build, and this we have to import the file into our pubspec.yaml. So let me come down over here. We will open our pubspec.yaml file, and let me just scroll down. Yes, this to do contract JSON we have to import it. So I have just imported it, and when we import it, we have to run flutter pub get, right? Okay, we have done. Apart from this, we have also imported few of the packages. Let me show you what we are going to use. So we are going to use a WebSocket channel. Okay, to create a WebSocket, we are using a Web3 Dart package over here to have our connection with Web3. Then we are using HTTP package. We are using provider to have our change notifier. Then to just create some time and date formatter, I'm going to use this package, and Cupertino icons that we get complementary with our application that I usually don't use. Okay, so coming back to our to-do controller that we have to create now. Okay, why? Because we will need a controller to create our application, because we have done linking our smart contracts by truffle migrate. Okay, and we have migrated them. So now we need a controller. So I'm going to command A and uncomment this everything. Okay, and let me come from the start. So we are going to use this RCP URL, but before that we extended our to-do controller to our change notifier. Okay, then we have created a list of to-dos that we created a model over here. let me minimize this contract. Yes, so we have module over here. So this is a module that we created, which takes a string ID, string title, string category, and date time created. Then we have created our constructor. From this constructor, to do from JSON and map string dynamic to JSON. And this is some dummy data that I have added, which we won't be using, but for your sake, that how we will be creating the data, I have added this over here. Okay, so we are importing this to do module into our controller over here into our controller. Then we need this URL, right? This URL, you will find it over here from our Gnash. So this is the URL that we need, http 127.0.0.1, and this is the port ID. Okay, so we have added this over here with the port. Now we also need a WS URL. So WS URL is the same as our RCP URL, but we just add WS instead of HTTP. Okay, that is the only difference. We need private key. So what is this private key? Is whenever we use Nash, we have to get a private key. So you can see this show key button over here, which also has a key symbol. So I will click it over here. I will copy it. Command C, done. I will minimize this because we don't need after this, but it should be running. And I would paste my link, or sorry, my private key over here. And we have created some variables. So first of all, we need a client variable, which has a data type of a Web3 client. Okay. Then we need API codes, which is a string value. We need credentials, which will store all our credentials. The Ethereum address, contact address. So deployed contract will be a contract. The contract we will be deploying, okay, because we have created them, but we have to deploy them. And then we have created this functions inside our controller that we are going to use. So contract function to do count, contract function to do's, contract function add to do, and contract function delete to do, edit to do. These were the functions which I showed you beforehand that we created. So we are just creating, and we are just creating a variable that will help us to use them. We are going to init the controller over here, and once the controller is init, we are just going to use this init function, which will help us to init the controller. Okay, and this is how we are going to do it over here. Now this Web3 client takes parameters like the RCP URL, which we have created on top. Okay, the socket connector, which will help us to connect with our IO web socket channel, okay, that we will be using with Nash over here. Coming down, we have created some ABI functions. Okay, now what are these ABI functions? So ABI helps us to create a Solidity contract and helps them to merge with our Nash that we are going to use it. This will help us to get the credentials that we have created, and the get deployed contract will help us to get all the contracts, all the smart contracts that we have deployed. So these are the three functions that we are going to need them. Okay, and the Ethereum address that we will need. So the Ethereum address is from JSON API that we get from here. Okay, we decode it, and we have to get the networks, the port that is over here running. If you see network ID 5777 and the address, okay, so that we will be using it. And in credentials, we will be passing our credentials from private key, the private key that we get over here. Okay, and we will deploy all our contracts that we have created, and a separate contract for a separate file. So over here, if you see, we have all the contracts built over here. Okay, these are all the contracts that we have built. Okay, and we will be deploying them one by one into our Gnash and our Solidity server that we will be using. So coming back over here, and yeah, so these are the functions that we have created. This will help us to get the to-dos that we will be adding over here. This is the function to add to-do, get all the to-do, add to-do, delete to-do, and edit to-do. So these are the functions that we will be needing. Okay, so coming back to our project over here, you can see where to use this project. For that, we will need the front end part, right? So we have created a nice front end over here. If you see screens, home screen, and we will need this delete to do function, and we'll also need a homes function to add. Okay, so over here we will need a function to add our to do list. Okay, but before going ahead, let us check the application. So I will just run my application over here. Let me see if it is running without any errors. There is also a file called as truffleconfig.js. So before running, make sure that you have just added the host, that is 127.0.0.1 over here. Okay, and we also added the port 745. And why is this happening? Okay, fine. Let's just wait for it to run. So you can copy this from our get started package, or you can also just write it down from here. Okay. And if you want to get this port ID and network ID is usually asterisk key, but you can also write 5777, or you can get the host from our Nash folder over here. Okay. So this is everything that we need. And I'm just taking my simulator, which is running now over here. Okay. Okay. Let me just stop it again and play it. Yeah. So pods are getting installed. It usually shouldn't take much time due to concurrent builds. Just let me clear my Flutter project. I also have a backup project which I've created. So if this doesn't work, then I will just shift to this project. Okay. This is a to-do backup which I might shift over here. The same project. So just let me hit the play button over here. Yeah, this is okay. Thank God. Whew. Okay, yes. So now I've got this error. So what happened is the key that I've used was the previous key. So just let me update the key over here. So I'll be coming back on top over here. I will open my Ganache. I will copy this key from here. Command C. Okay. I will change the key. Okay. I will navigate my project. I will pause it. I will open my terminal, and I will go to CD contracts, and I will run truffle migrate because I have to migrate my new contacts again. And I've already done this, so I'll have to use the reset keyword. But you guys won't need reset. All you guys will need is just truffle migrate. Okay. And now if I play over here, I think now this should work. And I've also added the two functions in this. Basically, what we will do is this will be a add to do async function. So when someone just writes on this and just clicks on the add function, yes. So this is our function. Our application has been loaded completely. So this is a blank screen right now because there is no to do added. So I will click on the plus sign over here, and we can see a nice UI where I can add. So over here I will add first uh, first task. I will give let's see, home, office, shopping. I just give a fun task, and we will add it over here. After adding, you can see, if you see over here, adding to do, that means our to do has been added. And if I'll go back, you can see we have our first task over here. So this is the function that we have added. So what this function do is it takes the to do from our list that we have from our controller text, okay, and it takes the ID. The ID I've given is the current milliseconds, okay, for since epoch to string, because I don't think we will have two similar IDs like this. The category is selected category, that is fun, and the title is to do text controller, that is a text, and created at datetime dot now. So when we do this, it gets created. The task is sent to our Solidity server in Gnash, and then we retrieve it back in our home screen. So the code in our home screen is as follow. Okay, so we have first created a to-do controller that keeps a track, okay, that we need. We have also added provider, okay, over here to the to-do controller. Then coming back, this is just a small plus button over here, which will a floating text button, a floating button, sorry, which will help us to add the task and to navigate us to the next screen. Okay, like this. Okay. Then I have wrapped this in safe area, and coming down, this is just a normal list view, which will help us to get all the tasks, okay, which will help us to get all the tasks. Now there is no get task function, if you see, because we actually don't need it over here, because when we add our to do, okay, when we add the to do, due to change notifier, it notifies our home screen that there is something in our to do list that we have created, and it updates automatically like this. Okay, it updates automatically like this. And when we click on this red button, it removes the task that we have added. Okay, so you can see how this is working. This is working like this. Okay, so we have used the web3 Gnash, and whenever we are creating any task, you can see the balance is reducing. It was 9.8, now it has become 9.6. So the more we use the balance, the more we create the task, the less balance we are left with. But this is a trial local server, so we have unlimited kind of ETH balance, so there won't be an issue. But when we'll upload this to the live server, that time you'll have to make sure about the balance that you have, or you'll have to buy extra balance over here. So this is what we have done over here. And yes, I think I was able to explain the topic very nicely. There was a small glitch in between about the application. Don't know what was the error, but thank God I had this second backup ready for it. Yes, I think this is done over here.